A projectile is launched from ground. The height of the projectile in feet after t seconds is given by this equation, which I can also say is negative 4t squared plus 16t. It opens down because of that negative. The parabola is going to look something like this. And now we're going to start answering questions. I'm shooting it up into the air, and of course, at some point, it's going to come down because we have something called gravity. At what time is the projectile at the height of 12 feet? I set h equal to 12, and I get 16t minus 4t squared. The only way I can solve this is setting it equal to 0. I'm going to switch everything up, and I'm going to make this 0 equals minus 4t squared plus 16t minus 12. And now I'm going to factor out a negative 4. So I have negative 4 times t squared minus 4t plus 3. And now I have to factor what's in the parentheses. This equals negative 4 times t minus 3 times t minus 1. At what time is the projectile, or times, is the projectile at a height of 12? The answer is, obviously, negative 4 is never going to equal 0, so I leave that alone. T minus 3 equals 0 is t equals 3, and t minus 1 equals 0 is t equals 1. These are the times where my projectile is at a height of 12 feet. How long does it take for the projectile to hit the ground? Well, what do you think I can do here? When the projectile hits the ground, the height above the ground is 0. How long does it take for the projectile to hit the ground? I want to go back to my original, and I want to say 0 equals negative 4t squared plus 16t. I'm going to factor that. I'll factor out the negative 4t times t minus 4. I have two places where I have two possibilities. T equals 0 or t equals 4. Now that should make sense because we said we launched from the ground. T equals 0, I'm on the ground. My graph would actually look pretty much like this. And then it would hit the ground again at t equals 4. I know at 0 it's on the ground, and I know at 4 it's on the ground. Parabolas are symmetric. It's got to be in the middle that is the highest point, doesn't it? We could just take the derivative, set it equal to 0, and find the maximum point. But we don't, at this point, know derivatives. Using my knowledge of parabolas, I know that it's symmetric, and so I know that it's at 2. Let's see what the answer is at 2. H of 2 is equal to 16 times 2 minus 4 times 2 squared, which is equal to 32 minus 16, which is 16. 1, 2, 3, 4. Okay, these are 4 each. 4, 8, 12, 16. So there's my parabola. That's the graph of h of t. This is using substitution. I mean, when I use substitution, I really want to just use whatever voltage there is that has no coefficient, because V1 is equal to 4V2 plus 10. Okay, and then all I have to do is plug that in. So I have 3 times V1. Well, I know V1 is 4V2 plus 10 plus 2V2 equals 2. And then distribute and solve. So I have 12V2 plus 30 plus 2V2 equals 2. 14V2 equals, I'm subtracting 30 from both sides, so I get negative 28, which means V2 is equal to negative 2. Once I know V2, I can plug it in here, and I would say V1 equals 4 times negative 2 plus 10, which is equal to negative 8 plus 10, which is equal to positive 2. If I call this an ordered pair, I would say V1 would be 2, comma, V2 would be negative 2, if my ordered pair was V1, comma, V2.